Okay, so we're going to talk about rotations, and rotations are one of the three congruence transformations that we've talked about. The others are translation, reflection, and then we have the rotation. Dilation we've not really discussed because the dilation is a non-congruence transformation. So we're going to start with rotations. All right, so we have rotations. A rotation, when you have a rotation, is you're actually rotating an object or a point around a fixed point. Fixed meaning it is not going to move. So when we say fixed, it's not going to move. Not that it was broken and we fixed it. It's fixed, okay? Won't move. It's not variable. Fixed and variable are different things. So it's not going to move. So we're going to rotate it around a fixed point. So basically what happens is we've got several types of rotations. Now you can rotate counterclockwise, clockwise, but we're going to rotate pretty much counterclockwise. When you have a coordinate plane, you have quadrant 1, quadrant 2, quadrant 3, quadrant 4. That is a counterclockwise scheme. So when we talk about rotations, unless it says or specifies that it's clockwise, it's going to be counterclockwise because that's the way we move. When you get into trigonometry, your unit circle, same thing. This is 0 degrees, this is 90, this is 270, this is 180, or sorry, this is 180, this is 270, this is 360. So you would be looking at something like this. And then this would also be 360, okay? But it depends on where our point starts. So I'm going to draw a graph, and I'm going to show you a rotation, and I'm going to show you how we rotate that particular point through three different types of rotations. All right, so the first one, I'm going to draw a graph. I'm going to label my grid 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's -5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Whoops, that's regular 5. So I've got my coordinate plane now. I've got my X and Y. I'm going to stick a point on here. I'm going to make that point right there. And I'm going to call that point P, and that will be at 4, 1. That's going to be our first point. Now, I want to do three things to point P. First thing I want to do with point P is I want to rotate it 90 degrees counterclockwise. So we're going to do number 1, we're going to rotate 90 degrees counterclockwise. So 90 degrees counterclockwise, that means I'm going to start here and I'm going to go 90 degrees over here. So there's a rule that we use for the rotations. When you rotate it counterclockwise, you flip the Y and the X, and the Y, the value that was in the Y place becomes opposite. So that's going to be my new point. So my original point, my pre-image, okay, this is always called your pre-image. Your pre-image is where you start. The image is where you finish. So I'm going to start at XY, which is, 4, 1. And following the format, I'm going to flip them. So now the 1 is first and the 4 is second. And then I'm going to make the value in the X place opposite. So now I'm at -1, 4. And that is my image for 90 degrees. That is my image for 90 degrees. So that's how we do a counterclockwise. You go from 4, 1 to -1, 4. So let's try a different point. Let's pick a different point and do another one. So let's do point Q right here. Q is at -2, -5. If I want to rotate point Q 90 degrees counterclockwise, I'm going to use this format. So Q is at -2, -5. So when I rotate it 90 degrees counterclockwise, I'm going to switch them. That becomes -5 and -2, and then I take the opposite. So that's +5, -2. And that is my image of Q. That's what that little apostrophe means. That means the image. That's how you tell where your pre-image is and your image. This right here is also a pre-image because it's where we start. So that is the format that you use when you want to go in a rotation of 90 degrees counterclockwise. Now, 90 degrees counterclockwise, it should be noted, that's the same thing as going 270 degrees clockwise. So whenever we see clockwise, we'll convert it to counterclockwise. So 90 degrees clockwise would be 270 degrees counterclockwise, etc. So now let's look at if we wanted to do it 180. So I'm going to draw another grid. We're still doing rotations. So here's my grid. So I'm going to make my grid, and then I'm going to look at now doing a full 180 degree rotation. So let's start here. Let's start with our same point. We have P at 4, 1. That was our starting point. But now I want to do 180 degrees. This is our second type, 180 degree counterclockwise. Now if you notice, for 180 degrees counterclockwise, that's going to be the same thing as 180 degrees clockwise, because 180 this way meets 180 this way. So same either way. Okay, so now the rule for that one is XY changes to opposite of X, opposite of Y. All you do is flip the signs on the number. So here's my pre-image, and I'm going to rotate it 180, which means my pre-image is at 4, 1. So I'm just going to change the signs to -4, -1. So I'm going to go over 1, 2, 3, 4 and down 1. There is P apostrophe, which is my image. If you'll notice, when you do a 180, you jump 2 quadrants. So if my first point is if my pre-image is in quadrant 1, the image is going to be in quadrant 3. If my pre-image is in quadrant 2, my image is going to be in quadrant 4. That's what you get for the 180s. Let's try one more. Okay, let's do a different point. Let's say I'm here, and we'll call this point Q, and this is at 1, -3. I want to rotate Q 180 degrees counterclockwise. So I'm going to rotate it. So Q is at 1, -3. And so I'm going to make it opposite, -1, +3. So -1, +3. There is my image of Q. That was my image. That was my pre-image. So that's how you do a rotation of 180. Now if you notice, you can count. If you look at P, P is 1 above and 4 over. So this is 4 over and 1 down. You can count how far they are from the X and Y axes as well, but you are going to be required to write the rule based on the picture. So you do need to know it both ways. All right, and so the last one, we'll slide over here. Actually, we'll just come down here. The last one that we have for rotations is a 270 degree rotation. So I'm going to be here. So I'm going to do a 270 degree rotation now, counterclockwise. So this is the third transformation, 270 degrees counterclockwise. Now this also is the same thing as 90 degrees clockwise. Remember we talked about the sum has to be 360? This is the same thing as a 90 degree clockwise rotation. Again, everything we're doing is around the origin. So let's start with our point again. Let's start with our 4, 1. That's our point P, 4, 1. If I want to rotate this 270 degrees, here's the formula. XY changes into Y opposite X. So as in the first one, when we looked at the 90 degree, Y and X switch places and you took the opposite of the Y value here. Now the Y and X switch places and you're taking the opposite of the X value. So let's look at P, 4, 1. And we're going to switch them, 1, 4, and we take the opposite. So 1, negative 4. So that's my P value. This is my pre-image, and this is my image. Again, okay, you're doing 270 degrees, all right? Sorry, 1, negative 4. I apologize, it would be over here. So 1, negative 4, P would be 1, negative 4, and that's your image. Notice when it's 270 and 90, they're only one quadrant away from each other. When it's 180, they skip a quadrant. Okay. If I were to keep rotating these, especially if I did the 90, going back to the 90, if I were to keep rotating the 90, 90, 90, 90, and 90, after 3 rotations, I would be back where I started. 90, 2, actually 4 rotations, 3, 4 rotations, I'd be back where I started. So let's pick one more on the 270. So we'll pick one more on the 270. So let's look at, on this particular graph here, if I make Q here, Q will be at negative 1, 2. So I'm at negative 1, 2, and I'm going 270 degrees counterclockwise. That means I'm going to be at, I'm going to switch them, 2, negative 1, and then I'm going to switch the sign on the second one, so that becomes 2, positive 1. And there's my image of Q right there. So that is how you do rotations.